So this was a weekly pop quiz that is related to mostly topic of waves. You can mention a question or a doubt if you have in this. Any doubt in question one? Question one, any doubt? Question two, any doubt? Okay. Question two. In question two, in a progressive water wave, when we say a progressive wave, means the wave will move from one place to another. Two particles P and Q on the surface of a water are fixed horizontal distance as oscillate vertically. Like these particles are oscillating vertically. At time t is equals to zero, that's how the wave will look like. When time is like the beginning, that t is equals to zero, that's how we observe the wave. Which graph best represent the variation with time, the phase difference? Look, what will happen for a progressive wave? The phase difference between the 2 points remain unchanged. I will give an example. When we mark the phase of this wave, so this is 0, this will be 90, this will be 180, this will be 270, and that is 360. So how much is the phase difference between the point P and Q? So P is at 90 and Q is at 360. So what is the phase difference between P and Q? So 360 minus 90, what we'll get? We'll get phase difference of 270 degrees. The difference in the phase, like 90 and 360. Now, because this is a progressive wave, so as progressive wave means it will move. So new position of a wave, let's say new position of a wave is like this. So this is the new position of the wave. The red line is representing the new position of a progressive wave. Now, what is the position of point P? The position of a point P is here, and this is the position of point Q. How much is the phase difference now if we compare? So this is 0, this one is 90 degrees, 180, and Q will be 270. So again, when you take a phase difference between point P and point Q, you will get the same value, 270 degrees. So whenever we have a progressive wave, the wave which travel from one place to another, the phase difference remain unchanged. So what is the right option? The phase difference between P and Q, it will remain constant or unchanged. That's why D will be the right answer. Is it clear? The option D. So this is always the case whenever we have a progressive wave. The progressive wave, the phase difference remain unchanged. Question 3, 4, any doubt? Question 3 or question 4, any doubt? Then we have question 5, 6, any doubt? Question 5 or question 6? Question 5 and question 6, okay. In question 5, a beam of a vertically polarized light is incident normally on a polarizing filter. The filter can rotate so that its plane is perpendicular to the beam. The transmission axis is of the filter is initially vertical. The filter is first rotated clockwise by an angle of 30, then so that the transmitted light have an intensity of I30. The filter is then rotated clockwise by further angle of a 30. What is the new intensity? So we have to use a law, like example, we know I is equals to I naught cosine 30 square. That's the relation between the light intensity which transmitted from the polarizing filter at different angles. When the cosine zero, like angle is zero, that time we'll have a maximum intensity because cosine zero is 1. So first this angle was 30 degrees. The light which passes through is I and the light which incident is I naught. So what is the relation between them? We have I equals I naught cosine 30 degrees and the whole square. And what we call this, we call that as I30. Like I30 means when the angle is 30, the light which is passes through, we call that as I30. Now we rotate further 30 degrees. If we rotate further 30 degrees, what will be the angle? The total angle. If we further rotate 30 degrees, so means the total angle will be 60 degrees. Because this is 30, then another 30, so total angle will be 60 degrees. We always take the total angle from the vertical axis. This theta is always the angle. Like example, you have a polarizing filter and you have a polarized light and you have a polarizing filter. So you always take the angle from the initial value. So first we rotated 30 degrees and then further we rotated 30. So the total angle will be 60 degree. So I60, the new will be is equals to I naught cosine 60 square. Now we want to compare these two equations when the angle, say this is equation A and this one is equation B. We want to compare the two equations. We always take the total angle from the axis, original axis. So if I write this, if I change this equation, so it will be I30 divided by cosine 30 square is equals to I naught. And for this equation, I60 is equals to cosine 60 square is equals to I naught. So I can compare these two equations. I can compare because I naught will is a maximum intensity which is I naught. So we can compare these two equations. We can say I60 divided by cosine 60 whole square is equals to I30 divided by cosine 30 whole square. So when we simplify this, so I60 will be equals to I30 times cosine 60 whole square divided by cosine 30 whole square. So what's the answer? Cosine 60 whole square divided by cosine 30 whole square. When you simplify this factor, so I60, the intensity of a light when the angle is 60 will be equals to when cosine 60 whole square divided by cosine. Why we are comparing the two values? Because all the answers are in I30. That's why we are comparing. Like it is a comparison when the angle is 30 degrees and when the angle is 60 degree, by what factor the light has passes through when the angle is 60 degree, because all the answers are given in I30. That's why it is a comparison. So it will be 0.33. You have to square cosine 60 square divided by cosine 30 square. So it is 0.33 I naught. So that's why B will be the right answer. Now, first what you do, how to solve this? First you have to take cosine 60, then take a square, then take a cosine 30, then take a square and divide them. This factor, the value of this factor is 0.33. Why we are comparing? Because all the answers are given in, if you see the options, all the answers are given in I30. Like it's a comparison. Compare to I30, how much the light has passes through. So originally, like I will repeat, look, original intensity was I naught and the filter was at an angle of 30. And this is like example, the polarized light, a filter was at an angle of 30. The light which passes through, that is called the intensity of light which is passes through, we call I30, and which is equals to the maximum light and cosine 30 whole square. Then they said the polarizing filter is further rotated and by 30 degrees. So if further rotated by 30 degrees, how much the angle is there between the original intensity, original light and the new plane of the polarizing filter? That is 60 degrees. Because first it was rotated 30, then further 30. Further 30 means total angle from the original is now 60. So the new intensity, which is I 60, is equals to I naught cosine 60 whole square. Now, because all the options are in given in I 30, like it's a comparison, that's why what we did, I naught will be same for both of them, the maximum intensity. That's why we compare the two equation to state the final answer in terms of I 30. Is it clear? So why it is compared? So the main reason of comparing is because the options are always or are given in comparison. Question 6. Question 6, it's a musical instrument made from a long tube with a mouthpiece at one end and the other end open and flare as shown. A musician maintain a stationary sound wave with a node at the mouthpiece. So node is formed here. What kind of pipe is this? Is this an open pipe or a closed pipe? If a node is forming at the end, which pipe is this? If a node is forming at the end, open or closed? No, this is called a closed pipe because if it was an open pipe always antinode will form at the end. If it is a closed pipe, when we consider the pipe is closed, node will form at one end and antinode will form on the other end. So if we have an open pipe, what is the frequency of the open pipe? If it is vibrating in one loop, if it is F1, if it vibrating in two loops, it will be twice of F1. If it is vibrating in three loops, thrice of F1. If it is vibrating in four loops, four times F1. But if it is a closed pipe, what are the comparison? The first frequency, if we say F1, the second loop frequency will be 3F1. The third loop frequency will be 5F1. Fourth loop frequency will be 7F1. Fifth loop frequency will be 9F1 and so on. Like multiple of the odd number. So which different frequency of a sound can produce by the instrument. The original frequency is 92 and it's a closed pipe because how we know it's a closed pipe as I mentioned here that a musician maintain a stationary sound wave with a node at the mouthpiece. So if the node is forming at one end, so antinode definitely will form at the other end. So this is an example of a closed pipe. So for a closed pipe, the frequencies are multiple of odd number, like 1F1, 3F1, 5F1, and so on. So which one is a multiple here of, like first is F1, F1 is 92, so first frequency will be 92. What should be the second frequency? If it is a closed pipe, the second frequency will be, so it will be three times, so it will three times, so 3 multiplied by this, so we'll get 276. What about the next frequency? So it will be 460. Because if this is F1, this will be 3F1. 3 multiplied by 92. This will be 5 multiplied by 92. This will be 7 multiplied by 92. So 7 multiplied by 92, what's the answer? 644. So with reference to that, what will be the answer? The answer will be C.